Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will review everything you need to know for the upcoming test on measurement. So let's start with converting units. So here we have a square that's 1 meter by 1 meter. So its area in meters squared is just 1 meter squared. But remember, 1 meter is 100 centimeters. So if I want to find the area of this square in centimeters squared, it's 100 by 100, which is 10,000. So even though there are 100 centimeters in a meter, there are 10,000 centimeters squared in 1 meter squared. So why is that? Well, when you're converting square units like meter squared to centimeters squared, you need to square the conversion factors. So here's a chart of conversions. Each of these numbers is called a conversion factor. So when we're converting square units, everything here needs to be squared. So the rule of thumb is if you are going from a smaller to a larger unit, you divide because there are fewer of the larger unit. If you're going from a larger to smaller unit, you times because there are more of the smaller unit. It works similarly for converting cubic units. If you want to convert between cubic units, you need to cube the conversion factors. So you can put these conversion charts right on your notes. So if you have something like 0.8 meters squared and you want to convert to centimeters squared, just remember you don't square the 0.8, only the conversion factor. So 0.8 meters squared, if I want to go to centimeters squared, I just times 0.8 by 100 squared and I would get 8,000. So I just want to go through again what a hectare is. So a hectare is actually 100 meters by 100 meters. So 1 hectare is 10,000 square meters. But of course, this is 0.1 by 0.1. So 0.01 kilometers squared. So there are 10,000 square meters in a hectare. There are 100 hectares in a kilometer squared. All right, let's now look at calculating some areas. So to calculate areas, you need to know the formula. Make sure they're on your notes. So this shape here, a quadrilateral with just one pair of parallel sides, is a trapezium, and we use this formula. So the area here would be h, which is always perpendicular height, divided by 2 times the sum of the two parallel sides. So just 1.5 times 20, it's 30. If no units are written, just write units squared for area. So this shape here is a kite. We know that because it has 2 pairs of adjacent equal sides. Note that all rhombuses are kites, so we can also use this formula for a rhombus. So how do we find the area? What we do is simply multiply together the 2 diagonals and divide by 2. So this will just be 60. Once again, I write units squared. So a parallelogram is a 4-sided shape with 2 pairs of parallel sides. So this side here and this side here would be parallel also. So to find the area of a parallelogram, it's just base times perpendicular height. The 11 here doesn't help us with the area. The area here would simply be 10 times 8, and that will give us 80 units squared. So let's take a second quickly to look at triangles. So when we're looking for the area of triangles, how we figure it out depends on the type of triangle. So here we have a right-angled triangle. We know this because 3 squared plus 4 squared equals 5 squared. These 3 numbers form a Pythagorean triad, meaning that the triangle must be right-angled. So when you have the perpendicular height of a triangle, it's easiest just to use the formula base times height over 2. So in this case, it would just be 4 times 3 divided by 2, which gives us 6. Again, just write units squared for area if no units are given. Here we have an equilateral triangle. So if the triangle you have is either equilateral or isosceles, you can divide it into 2 congruent right-angled triangles. So this side here would be 3, half of 6. We have a right-angled triangle. To find the area, I'm going to find the perpendicular height using Pythagoras. Because we're finding a shorter side, we minus. So it'll be the square root of 6 squared minus 3 squared, which is the square root of 27. I write it like this rather than the decimal point because I want to use this in a subsequent step. So the area of this triangle will simply be base 6 times perpendicular height divided by 2. So to 2 decimal places, that gives us about 15.59. Because the lengths were given in centimetres, it'll be centimetres squared. So we can only use this trick for equilateral and isosceles triangles. What about for a scalene triangle? We don't have an easy way to calculate the perpendicular height, so we have to use Heron's formula. So this is Heron's formula, where A, B, and C are the side lengths, and S is the semi-perimeter, half the perimeter. So in this triangle here, S would be 5 plus 2, 7 plus 4 is 11 over 2. Half the perimeter is 5.5. So the actual area of this triangle will be the square root of S times S minus A. It doesn't matter which you call A, which you call B, which you call C. So S minus A, 5.5 minus 5 times 5.5 minus 4 times 5.5 minus 2, and put that straight in your calculator. So we should get around about 3.8, because the units were in meters, it'll be in meters squared. So note, Pythagoras' theorem also allows us to tell whether a triangle is right-angled, acute angled, or obtuse angled. So in this triangle, 2 squared plus 4 squared is 20. It's less than 5 squared, so this must be an obtuse angled triangle. A squared plus B squared equals C squared means it's right-angled. A squared plus B squared is greater than C squared, then it's acute angled. A squared plus B squared is less than C squared, like in this triangle, then it's obtuse angled. All right, let's now look at some volume and surface area. So to find the volume of any prism, just use the formula AH, volume equals area of base times height. So even though a cylinder is technically not a prism, it still follows this formula. So here we have a rectangular prism. So the area of the base, the rectangular base, is 4 times 10, and then we just times that by the height, which is also 4. So putting this on our calculator, we get 160 meters cubed. So note, 1 meter cubed is 1,000 liters. So this rectangular prism could hold 160,000 liters of liquid. So let's now calculate the volume of this shape here. So it still follows area of the base times the height. Now the area of a circle is pi times radius squared. So the radius is half the diameter. So the diameter goes from one side of the circle to the other through the center. So if the diameter is 6, the radius is 3. The area of this circular top will be pi times 3 squared. So then for a prism or a cylinder, we just take the area of the base and times by the height. So putting that on our calculator, we get about 169.65 meters cubed. So what about surface area? Well, for the surface area of any shape, just add the area of each of its faces. So the total surface area of the rectangular prism, assuming it's closed, it has 6 rectangular faces. So 2 of them are 4 by 4 squares, and then there is a rectangle at the side of each side that's 10 by 4, and then top and bottom also 10 by 4 rectangle. So the formula is 2 times length times width plus length times height plus width times height. So putting that on our calculator, we get 192. This is in units squared. So the total surface area for a cylinder, it's still the same idea. You find the area of each face and add them together, but it might be easier to use a formula. 2 pi r squared, that's the circle at the top and the bottom, and 2 pi rh is this, the lateral face, the curved face. So if we put this in our calculator, we're putting in 2 pi r squared plus 2 pi rh. We turns out get the same numerical value as for the volume. So it's approximately 169.65, but this time it'll be meters squared. All right, let's look now at a triangular prism. So here we have a triangular prism. Because it's a prism, the volume will be the area of the base times the height. So the area of the base, the area of the equilateral triangle, there is a formula for equilateral triangles that makes life easier. It's root 3 over 4s squared. So if the side length is 10, this here will be the area of the equilateral triangle with side length 10. So that's the area of the base, and we simply multiply that by the perpendicular height of the prism. And so this time I'll just do it to one decimal place. It's 519.6, and of course it's in units cubed because we're in volume. So note, a centimetre cubed is a milliliter, so this would hold about 520 millilitres. So for the surface area of this shape, we just add each of its faces, the area of each of its faces. So we know that the triangles are going to have area root 3 on 4 times 10 squared, and there are 2 of them, which is y times by 2. Now we have to add the area of the 3 rectangles. Well, it's just going to be 10 times 12 plus 10 times 12 at the bottom plus 10 times 12 on the side. A quick way to do that is just multiply the perimeter by the perimeter of the base, that is, sorry, by the perpendicular height. So the perimeter of the triangle is 30. We just multiply that by 12. And so putting that in our calculator, we get about 446.6, and this time it will be in units squared. So now let's look at cones, or in particular tapered solids. Unlike a prism, they don't have the base repeated at the top. They don't have the same shape at the top and the bottom. Instead, they converge to a point. So when you're finding the volume of a tapered solid, a cone or a pyramid, it's still area of the base times the height, but you need to divide by 3. So in this particular case, the area of the base, the area of the circle at the bottom, is pi times radius squared. Radius is half the diameter, times the perpendicular height, but you need to divide by 3 for a tapered solid. So this time I'll give it to 2 decimal places. It's about 1,017.88 millimeters cubed. Okay, so what about the total surface area of a cone? Well, again, it is the sum of the area of each of the faces. So it has this circular face that's pi r squared, and it turns out its lateral face is pi rs. So s happens to be the slant height. That's why it's called s. So how would we find s? Well, we're going to use Pythagoras. We've got one side 12, one side 9. So the slant height using Pythagoras is the square root of 12 squared plus 9 squared. So we add in Pythagoras when finding the length of a longer side. So that will actually be 15 millimeters. So the total surface area of this cone is pi times radius squared plus pi times radius times slant height. And to 2 decimal places, that's about 678.58, and surface area is always in units squared. So that's millimeters squared. All right, let's look now at some harder problems. So in each of these questions, we're going to have to find a side from a measurement like a volume or surface area. So whenever that happens, write the formula, substitute what you do know, and rearrange for what you don't know. So since this question is talking about the area of a trapezium, we're going to write the area of a trapezium formula. Now we're going to substitute in everything we know. So we're told in this question the area of the trapezium is 120, and we're also told that the height is 6. So let's rub them out and replace. So we have here an equation with 2 unknowns that we wouldn't ordinarily be able to solve. But because we know that the parallel sides, which are A and B, are in the ratio 5 to 3, we can solve them. We can solve this because we can write these parallel sides as 5x and 3x, because they're in the ratio 5 to 3. So of course 6 over 2 is just 3, and 5x plus 3x is just 8x. So we've got 120 equals 24 times x, so that means x is just 5. So that means that the 2 parallel sides will be 5 times 5, which is 25, and 3 times 5, which is 15. So we are done the question. Now in this second question, we're asked to calculate the surface area of a sphere that holds 4 litres of liquid. It might not be immediately obvious to you, but we are asked to find a side. You see, we can't find the surface area of a sphere without knowing its radius. So we have to first find its radius. So another formula you might like to add to your sheet is the volume of a sphere, 4 over 3 pi r cubed. So let's substitute what we do know. We know that the volume is 4 litres, but I don't want to substitute V for 4 because it's not a unit of length. Radius is obviously going to be in centimetres, metres, or whatever. So we want this to be in centimetres or metres, or whatever. So 4 litres is 4,000 centimetres cubed. So let's go ahead and solve this. So the first step in solving this is divide each side by 4 over 3. So I get 3,000 equals pi r cubed. I want to get r by itself, so I need to divide by pi. Now I'm not going to put 3,000 over pi on my calculator yet, because I'm going to use this in the next step of my equation. So I want it exact. So the way I undo cubing, r cubed, is to cubed root. So I'm going to put the cube root of 3,000 over pi on my calculator. That will be r. So if I put this on my calculator, I get that the radius is about 9.8475 centimetres, because this was centimetres cubed. But the thing is, I now need to find the surface area. So the total surface area of a sphere is just 4 pi r squared. So I've got to use this value here for r. But rather than rounding it so that my answer will be inaccurate, I'm going to type in my calculator 4 pi answer squared. This is the last answer on my calculator, so I recall it. I just go 4 pi answer squared, and that will give me the total surface area. And so to one decimal place, I get about 1218.6 centimetres squared. All right, let's now have just a quick look at what happens when you double or triple the dimensions of a shape. So I have 2 squares here. So clearly the area of this square is going to be 1 metre squared. And clearly the area of the bigger squared is going to be 4 metres squared. So notice what happened when I multiply the sides by 2. When I double the sides, I've actually multiplied the area by 4. So this is not a coincidence. It turns out if you multiply the sides of any shape by k, then the area is going to be multiplied by k squared. So if I triple the sides of a square, it multiplies the area by 9. Now I only showed you that this works for squares, but that means it'll work for every single shape, because when we calculate area, we're really just finding how many of these squares fit inside a shape. So for example, even if a circle has area 20 meters squared, it means 20 of these little squares fit inside. So this will work for any shape. So if I increase the radius of a circle by 10%, by what percentage will its area increase? So if I increase a number by 10%, I'm timesing it by 1.1. So that means that the area will be multiplied by 1.1 squared, which is 121. So note that multiplying a number by 1.21 is the same as increasing it by 21%. So if you increase the sides of any shape by 10%, its area will increase by 21%. So what about this one? I want to double the volume of a prism. By what percentage must I increase its side lengths? Well, we've shown how it works in 2 dimensions. It turns out for 3 dimensions, it follows quite logically. If you multiply the sides of a 3D shape by k, the volume is multiplied by k cubed. If I multiply, say, the sides of a cube by 3, then the volume's multiplied by 3 times 3 times 3, which is 27. So if I want to double the volume, I'm timing its volume by 2. So 2 is like our k cubed. That means I have to multiply the sides by the cube root of 2. Now the cube root of 2 is about 1.26. So if I want to double the volume of any prism and have it still remain a prism, I need to multiply each side by 1.26, because 1.26 times 1.26 times 1.26 gives me 2. And of course, multiplying a number by 1.26 is the same as increasing by 26%. So that's our final answer. All right, thank you so much for tuning into this video. Best of luck studying, but you're a star, you will ace it. This has been the luckiest maths teacher in the world. Have a great day.